All right, welcome back, guys. So in this video, we are going to classify this shape using that same flowchart that we've seen before. So once again, the first thing I did was I went ahead and plotted all of it. I connected my points and I labeled them A, B, C, D. You can label them however you want, but you do need to have some sort of classification so that when we're talking about segments, we can classify them based on their endpoints. So looking at this immediately, my first gut instinct, honestly, could be three options. This might be a rhombus. This might be a kite. It might be a square. Um, but those are my three guesses. And honestly, might also just be a normal parallelogram. I'm not completely positive. So looking at our flowchart, the first thing we said we always want to do is determine, are the opposite sides parallel? So the very first thing I have to do is find the slopes of all of my sides. So I'm going to start with AB. 6 minus 1 is 5, and -4 there. And so I want to see, is AB parallel to CD? So that's the very next one that I check. And we get 5 over -4 again. So yes, these ones are parallel. That means that out of my options, kite's out, because we have at least one set of sides that are parallel. This definitely is not a kite. But it could be in the area of parallelograms. It could also be a trapezoid. I'm not positive here. So now I'm going to compare AD and CB. So looking here, I got kind of gut reaction, 5/4, -5/4. Many of you guys are probably going to say those aren't the same, but we know that this would actually simplify down to 5/4, and so therefore they are the same. And so we can follow that first step of yes, not all. The word I was looking there for is both. Both sets of opposite sides are parallel. So this is a type of parallelogram. So that was following this very first step. We said over here, yes, they are all the same. They are all parallel. So we're going to go ahead and move on to our next question then. Are the angles 90 degrees? So once again, when we're comparing the angles, we're looking here at the lines that intersect. So in order to determine if this is 90 degrees, I need to compare AD and AB. So I'm going to come over here and say AD versus the slope of AB. Those are the ones that I'm looking at. The good news is we already found those. AD is 5/4 and AB is -5/4. Nope. Now some of you guys are going to say, yeah, those are parallel because they're so similar to each other. Or sorry, perpendicular because they're so similar to each other. But they are opposite, but they are not reciprocals. So these are not 90 degrees. Now, I always like to double check because if I mess something here, it may have just told me that I calculated something wrong. So I'm going to see, is AB and CD also not? So what I say this were AB versus BC. So once again, if one of these come out perpendicular and the other ones don't, that means I probably did something wrong up here and I would want to double check. And so I just want to compare these as well. AB once again was -5/4. BC, which is also CB, is 5/4. Once again, no, those are not. So my statement would be here, no, the intersecting slopes are not perpendicular. So the angles are not 90 degrees. Therefore, the shape can only be, that says only, a parallelogram or a rhombus. And you might say, how do I know that? Well, this is just knowing my properties of quadrilaterals. I know that in order for, if they happen 90 degrees, be square or rectangle. So knowing my definitions there from the get-go. But also, if I were to come back over to our flow chart, are the angles 90 degrees? We're here, no. So my only two options, if I keep following, would be a rhombus or a parallelogram. So knowing how my flow chart goes. The last thing then that we need to decide are all four sides congruent? Once again, because it's a parallelogram, we already know that AD and CB are the same length. We already know that AB and CD are the same length. So we actually only need to determine, are our red and purple lines the same length? So in order to do that, I'm going to find the distance of AD and the distance of AB. So for AD, my change in X is between 0 and -4, that's 4. My change in Y is between 6 and 1, that's 5. That's going to give me 16 plus 25, which gives me 31, 41. Let's see. And now if I come over here, let's do the same thing. So for AB, the change in X is 4, and the change in Y is 5. Immediately, I see that these are the same, so I say, yes, they are the same length. I could work it all the way out. We would obviously get the same thing. So I'd say, because all four sides are the same, this parallelogram is a rhombus. Final conclusion, rhombus. If we come back over here, that's because we were able to answer this question, yes, and we came down to a rhombus. So notice I wasn't done until once again I made myself all the way down here. We can't ever stop up towards the top of the flow chart. And so if you follow yourself all the way down, you're going to know that you have a full proof on your hands.